All right, well, here's a circuit based on Co Tillman's circuit over at Radio Fun 232 that he just posted the other day. Interesting circuit here. Runs on two AA batteries. It's got a tap in between the batteries, and the PNP is running off the positive side of the bank, and the NPN is running off the negative side of the bank. But then Co added this preamp over here. Now I tried to build this circuit and basically I couldn't get it to work with this installed, so I took that out. I asked Co for the original schematic. He kindly sent me links to this book. It's an incredible book. It's called The Book of the Transistor. And on page 23, figure 19, is a beautiful schematic. Look at these rounded corners. This is just, it's art. There's some non-standard kind of ways to represent things here, like this connection should be up here, but you get the idea. So this circuit is what they're calling a push-pull, and that's exactly the same circuit as this. Now all Co did, he integrated a preamp. Let's listen to the circuit. The cool thing about this circuit is it will run on one battery, two batteries, or either battery. Now I've cranked up the volume full blast on the iPod. It's plenty loud. Now I'll demonstrate running the circuit on half power. It's interesting because what you're essentially doing is unpowering one or the other transistor. So that's running off of this transistor. And there's this transistor is being powered. Oop, get a drop out here. So the challenge of working on a breadboard is stuff is jiggly, of course. All right. It's pretty clean signal, not too much distortion. Now here's the thing about this that's interesting. I've only got one capacitor, and I am not able to make this work with the 100 nanofarad capacitors that Co is using over at Radio Fun 232. He's specifying using 100N all the way across the board. The little 104s, the 103s, those don't work at all for me. Yeah, I'll show you what I mean. Turn up the volume. We'll take out this capacitor, and we'll put in this one. Is marked 104, so I believe that's a 100 nanofarad. And yeah, you can hear something coming through, but it's not a lot. This little guy. So basically, it's just killing all of my volume, all of my amplitude is going away. This is a 10 microfarad. So that's interesting. Here's another funny thing about this circuit. Like all good circuits, you got a capacitor to keep the DC voltage from creeping back into the audio signal. Well, all right. Here I'm going to bypass that. And you get a little bit of distortion, understandably. And this cap is acting like a high-pass filter. Okay, great, but where's the other capacitor for the other input? Well, when I use two capacitors, it kills the entire signal. It just goes away. I will demonstrate. Alright, so I'm going to put in the 10 microfarad where it belongs, and it should be going from input to the base. Input to the base. So I've got input to the base of this transistor, and we're going to go input here. We're going to get this bodger out of there. Weird stuff is happening already. What happened? It's gone. The signal's gone. Weird, right? It's weird. I don't get it. So what I did was, I said, okay, we'll use one capacitor to rule them all, and we'll just use a tiny jumper to jump it over to the other base input. So this capacitor is filtering the input for both transistors. You know, that doesn't seem completely illegitimate. Okay, here's another weird thing about this, is I took off the biasing between base and emitter on both transistors. The only biasing there is, what is that? A 10K going between the center tap power and the two collectors, which are joined. And that joining the two collectors allows these two to operate in kind of a synergistic fashion. See, we're running on 1.5 volts. It's amazing. It's more distorted because it's imbalanced. It just sounds crazy. All right, now what have I done here? So now I've added two potentiometers to bias the base to collector junctions on both transistors, and let's see how that sounds. There's a bit of distortion. It's not terrible. I mean, the bass is really getting distorted though, for sure. But I'm overdriving it. You gotta remember this iPod, I was at full volume. So if I back it off, I mean, normally if you're gonna power into or plug into an external speaker, you're gonna be probably somewhere in the mid-range, right? You don't want to overdrive. Yeah, right? It's also weird. I can bypass this cap. I can bypass my one cap, and it doesn't sound terrible. I mean, it's gonna get more distorted the louder we overdrive it. I'm basically overdriving it. There it is. You can hear it. Okay, so we need the cap. It's got to be in it. I think. It's kind of cool though. I like the idea that it runs on like almost no electricity whatsoever. It'll run on half power. Which reminds me of old transistor radios that would come with two little AA batteries. You know, I'm talking like the 70s and 1980s. Old cheap little radios you could buy. They came from Taiwan usually back then. And they were well made, and they would run on this kind of battery situation, just a couple of small batteries. And I remember they would get more distorted the more spent the batteries were, you know. So another book that Co sent me was the Transistor Circuit Handbook, another very interesting book. I'll put links in the doobly-doo. Page 64, figure 412, we've got, this looks familiar. They describe this as a push-pull circuit. I think I mentioned that earlier. It's the same as this. It's the same as this side of the circuit. They say, this is circuit B that I'm talking about, complementary symmetry. Circuit B and circuit C utilize the complementary symmetrical characteristics of transistors of different types to obtain push-pull operation with a single-ended input and output. Cool, okay. And that also explains why using the center tap technique and powering each of these transistors independently, very cool. Allows you to run on old batteries, new batteries, one battery. Very cool. Well, that's about all I got for today on this. I think what I'd like to do is solder this up good and proper, dead bug style, and stick the speaker in a box. The tone is not too bad on this. I am a little confused about the biasing. It doesn't seem to improve or degrade the situation too much. I'm a little confused about the capacitance on the input. It's weird. But all in all, it's a very cool circuit. So that's about it. So thanks again, Co, over at Radio Fun 232. Really great resources you sent me, and probably a couple lifetimes worth of information in there. So very cool circuit. I'd never seen it before. I reckon it's fairly common in those older transistor radios that run on very little power. Yeah, if anybody out there has some suggestions about the capacitance issue that I ran into, feel free to let me know what you think. And as far as biasing or not biasing, it seems like you gotta bias the transistors in some way. Well, anywho, that's all I got. Have fun.